Okay, so in this case, the problem wants us to find the slope of the line tangent to the graph of x squared plus 2xy squared plus 3y equals 31 at the point 2 comma minus 3. Okay, so basically the idea, whenever they are asking you to find the slope of the line tangent, they are asking you to find the derivative of the function. The thing here is that we have x and y being multiplied together, which makes it kind of hard to find the derivative by solving for y. So in this case, we need to use implicit differentiation, right? Implicit differentiation is based on the product rule. So basically, you can use the product rule on each of the terms of the equation to get the derivative you are looking for. But I prefer basically on my side, I prefer to take derivative of each of the terms twice, one for x and one for y. So it is easier for me to have control of what's going on there. But you can use either method. You can use the product rule for each of the terms in the equation, or you can find the derivative of x first, then the derivative of y, and then solve. I will use this second method. So first, we start by taking the derivative of x of each of the terms in the equation. So, for example, the derivative of x squared will be 2x. Just a second. Will be 2x. And what I do is that I write a ddx next to the x. This is to let me know that I have taken the derivative about x or derivative of x. Next, I take the derivative of x of 2xy squared. In this case, we take y squared to be a constant, or we consider it to be a constant. So we don't really care about finding or taking the derivative of y squared. We just need to take the derivative of x. So the derivative of 2x will be just 2. And we just copy the y squared and write a ddx next to it to indicate we have taken the derivative of x. Since there is no x next to 3y, we take this to be a constant. So the derivative of a constant is just 0. So we just write plus 0 dx. So now we had already taken the derivative of each of the terms in the equation about x. Now it's time to take the derivative about y on each of the terms in the equation. So in this case, the derivative about y, we don't have a y in the first term, so we take this x squared as if it was a constant. So we just take the derivative of a constant, which is 0. But this time I write a dy next to the 0. Let's take the derivative of the next term. In this case, it will be 2xy squared. We do have a y here. The derivative of y squared is 2y. So this will basically be 2 times 2xy dy, right? The derivative of y squared is 2y. That's where this 2 came from. So it will be 2, or I can say that it will be 2x times 2y. 2y being 2y, the derivative of y squared. So next, the derivative of 3y will be just 3 dy. And all of this equals 0, because the derivative of a constant will always be 0. So this will all be equal to 0. So basically, this is our derivative. This is our derivative by using this differentiation. So now, all we need to do is reorder this. How do we do that? We leave all the dy's on the left side of the equation, and we move all the dx's to the right side of the equation. So we have 0 dy plus 4xy dy, because 2 times 2 is 4, so this is 4xy dy, plus 3 dy equals, this one moves will be subtracting on the left side, Notice we are treating this as if it was a regular equation. So this will be minus 2x dx minus 2y squared dx. This one becomes negative, and this one also becomes negative, minus 0 dx. The thing here is that we can get rid of these zeros we have here because they aren't doing anything to our problem. So we can get rid of this 0 dy, and we can get rid of this 0 dx. So we have the following. Okay, so next we can go ahead and factor. In this case, we need to factor the dy's and the dx's. The dx's. We are going to factor them, and you'll see why. When factoring the dy, we end up with 4xy plus 3 dy equals minus 2x minus 2y squared dx. Why did we do that? Because we wish to solve for the dy over, we need to solve for dy over dx, right? So we'll move this dx beneath the dy. They are going to be dividing. So this is 4xy plus 3 times dy over dx. And this will be equal to minus 2x minus 2y squared. Next, we can go ahead and move this 4xy plus 3 to divide this minus 2x minus 2y squared. So we end up with dy divided into dx equals minus 2x minus 2y squared divided into 4xy plus 3. And this is our derivative. Remember, the derivative represents the slope of a tangent line of a given curve. So, in this case, this will represent our slope. This derivative is our slope. But how do we find the exact slope? This is where the given point comes into play. We want to find the slope of the graph at the point 2, minus 3. This point tells us what x and what y are equal to. In this case, x equals 2 and y equals minus 3. Remember, the first number tells us x, the second number tells us y. So we can go ahead and substitute these two for all the x's in our derivative and this minus 3 in for all the y's in our derivative. So let's go ahead and do so. Okay, so we have our derivative here. All the x's will be changed for a 2. So this is a 2, this is a 2, and all the y's will be changed for a minus 3. So this is a minus 3, and this one is a minus 3. Okay, so that will be our derivative. So now let's solve it. Let's solve this derivative. This is mostly arithmetic. So minus 2 times 2 will be minus 4. Minus 3 squared becomes 9. So this will be minus 2 times 9. 4 times 2 times minus 3 is the same as 8 times minus 3. That will be minus 24. Minus 24 plus 3. So let's finish solving this. It will be minus 4 minus 18. Minus 24 plus 3 is the same as minus 21. So our final answer in this case will be dy over dx equals minus 22 divided into minus 21. These negative signs cancel each other, so we end up with an answer of 22 over 21. This will be the slope of a tangent line to the function or to the equation x squared plus 2xy squared plus 3y equals 31 at the point 2 comma minus 3. The answer will be 22 over 21. I hope this was helpful for you. Remember to follow my channel and like this video if this was useful for you. And if you need any live tutoring, you can click on the link below in the description.